Welcome everybody. We'll talk here about running Uyuni on Kubernetes, okay? But also how to get from there to something that's supportable as a product for you. I'm Cédric Bosdona, coming over from France. I know there are two fellow guys here from France. And I'm working in the SUSE Manager team for a bunch of years already. And I went through virtualization team, and I have been even hired in the beginning a long time ago to work on OpenOffice. So you see my background is legacy application oriented, right? Just a quick round here. How many of you are using SUSE Manager or Uyuni? And how many are Kubernetes aware? Okay, or well, so let's get started. So first we'll go through what is Uyuni, because obviously it has to be reminded at some point. And Uyuni and SUSE Manager or SUSE Manager are running on Kubernetes. Does it make sense? Why doing that? Why not? And the obvious question is, are we there yet, right? The usual question from the kids, 5 minutes after sitting in the car, are we there yet, right? That's about the same. So what is Uyuni? Uyuni is the upstream project, open source upstream project for SUSE Multi-Linux Manager. I can't remember when it has been open source. Uyuni is a fork from Spacewalk. I think this is the Uyuni is dating from 2018. Correct me if I'm wrong, but something like that, right? And Spacewalk, we have the initial commit of Spacewalk you can find in GitHub dates from 2008. And given the size of the commit there, we can assume it has been around for a few years before. So the code we're tampering with is about 20 years old, probably even more. That's a real mystery. We have no real knowledge of what happened before 2008. It was Satellite 5, but you know, that's where we are and where we're coming from. So why should you care about Uyuni, right? You should care about it because that's where we're incubating our new features, where people are contributing to. And while the features are there, it gets more time to test them, to improve them before they're landing in SUSE Manager. That helps us getting early bug reports on them, of course. And there are some features that are coming in and supported in SUSE Manager pretty fast. And some are in tech preview for a longer time because they're not ready yet. So it's not because it's Uyuni that it will be in the next SUSE Manager, right? It's a bit more complex than that. Typically, Uyuni is already capable to run on Kubernetes. But it's not there yet in SUSE Manager. And we'll see how that goes. Uyuni is a community effort, and this is something I'm reminding every day to my fellow colleagues. So this is a community effort, and besides SUSE, there are people contributing to translations, documentations, new operating system supports. One of the latest obvious ones in date is Ubuntu 2024.04 has been contributed by a community member. And well, it took us probably too long to review properly and test and get it merged, but it's been merged in the end. And we also have new features and bug fixes that are contributed in there. Some example of code contributions we have For instance, we have a guy in the community who built and ran Uyuni on EL8 and EL9 for a lot of time. Now it doesn't make any more sense because as it's running as a container, it's too easy. I mean, it doesn't need to build to tweak the packages and so on to get it done. It's just using the same container and that's it. But he did an amazing job doing that for multiple years. Christian, he's running around the corridors here from SVI, has done some work on getting some integration between Ansible and Uyuni as well. That's pretty cool. And we have also Google Summer of Code students. If you're still here on Friday, I'll talk about Google Summer of Code at OpenSUSE at the Early Access Tech Summit. That's happening here. And the outstanding project to mention here for Uyuni. So we had one on accessibility fixes on the web UI. 2 years ago, we had another one on OVAL data support. So consuming OVAL data for the audit, CV auditing. This happened 2 years ago, and it took quite a lot of time to fully review the pull request, getting it bulletproof, and the last bits of this work is being merged these days or weeks, or is going to come soon. And that will come in SUSE Manager and 5.1, maybe even 5.0 or something. I can't remember, but that's coming soon. And last year, a student worked on a lazy reposync. So you know reposync is pulling all RPMs and extracting data from here. And then the idea here is started working on that, is doing the reverse, getting the metadata from the repository and then pulling the RPMs later. So this work in progress, but it's cool work that's done by others. And this year, again, we're participating in Google Summer of Code. So let's see what will come out there. Let's see a few tiny things. A small quiz. I'll show you a few screenshots, and let's see if it's running SUSE Manager or Uyuni, right? If you run mgrctl and you see this, is it SUSE Manager or is it Uyuni? Well, in fact, you don't know. You don't know. It's not because it's written Uyuni server here that it has to be Uyuni. It's the internal name of the container, of the internal host name of the container. So it's the same whether it's running Uyuni or SUSE Manager. It's the same thing. If you see that, don't be scared. You never know what it is. It's not reliable to indicate. And you even see that above here we have a spacewalk.target, right? So we have the upstream names, even the old ones that are popping up here, some here and there in the command lines and in the container. So you have even rhn-something command, right? coming from Red Hat Network even. So Uyuni is one of them. It's just a new upstream. This one, we have an Uyuni server.service also on the host. And that's basically the same thing. Is there whatever. So this service is the service that starts the main container. Whether it's SUSE Manager or Uyuni, it's named exactly the same way. It doesn't mean it's running Uyuni or SUSE Manager. So next, this one. So Podman inspect Uyuni server, and then I'm grepping for SUSE Manager server. When you see this is a SUSE Manager server, because these labels here are added at build time by our internal build service, and only SUSE Manager has them. You have Uyuni, you have several different one for Uyuni and SUSE Manager. This is reliable. And in the web UI, you have that in the corner at the bottom. This is reliable as well. But maybe you already knew, right? No? I, well, I think I had to say that, to give that away, because I usually had the question from time to time, hey, I see that Uyuni server, but I'm supposed to run SUSE Manager. Yeah. That's not indicating anything. So let's go on the Kubernetes topic. Does it make sense, and why we want to do that? So in the beginning, when we said we wanted to containerize SUSE Manager, I first wanted to get directly to run that thing on a K3s for everyone and just have one deployment way. And I've been told, no, it's not possible. Okay, and then after time I realized that that's true. We have people we have a large user base who is coming from the Linux world, and they're not used to containers. And in some cases, I even had a chat with a customer earlier today who is using folder 3 and has problems moving to folder 5.0 because there's a container running in there. And what is a container has to be handled by a separate team, even if it's running by Podman and not by Kubernetes. So I discovered after time that we have that segregation and that's not easy to overcome. So we have to have that Podman-based containers that is almost like the RPM thing, but not quite. It brings some of the values, at least for us, because it's a container and we can ship it on different OSs. The typical use case here at the beginning of SUSE Manager 5.0, it was only allowed to run on the Micro 5.5. And we realized that we had to open that to /15sp6. And opening that to /15sp6 technically was easy. The only trouble is that it adds more work for the people testing it, but that's basically the same thing. And we're not limited about all the dependencies coming from / or whatever. So we're really we can really do whatever we want in that container. It's way easier for us on the dependency side. And to make this easier for everyone who spent a lot of time on an MGR ADM tool that's allowing you to deploy the container, not having to bother about all the internal details and so on. And so this is the approach for Podman and why we did that on Podman. Just taking care of our legacy users the installed user base and the fact that they're not at ease with containers. And then we have different target audience, people who already know Kubernetes. And I realized after time that the more we go to Kubernetes, the more I go into something that is more like cloud native, cloud friendly, running SUSE Manager on Kubernetes, the more we have to rely on the user being able to provide us secrets, configuration, config maps, volumes, network setup, and whatever. And we have to rely on them having knowledge. So we cannot assume a customer or a user having zero Kubernetes knowledge to go with this. Not possible. So there's different audiences here. And obviously with Kubernetes, you could get some of the cluster benefits. We'll go through that a little bit afterwards. So what could we expect by running SUSE Manager on Kubernetes? So I picked up a few. I asked a colleague, sales architect, and asked him what are the key advantages of running an application in Kubernetes. He will list. Gave me 6 of them, and I tried to match if we could do that, right? So yes, we can have it. Because if you have a shared storage across all the nodes of the cluster, if the node running the server goes down, It'll pop up later on the other side. Fine, soon, no problem. You can rely on Kubernetes features for that, no problem. Scalability, no. Why? Because for now, we have one giant container. This is basically behaving like a VM. And we cannot scale that. We even have a PostgreSQL database still inside. Cannot scale that. And even when we extract the database, we cannot still scale the whole thing, everything out. And this is something I'm trying to explain to people on the way to, even before at the kiosk where we have the demos here. The goal is not to have the full benefits of Kubernetes and cloud-native applications on everything, because it's not possible. That means we would have to rewrite the whole thing, right? And that's not. We don't have the resources to do that, and we don't want to risk everything for that. But there are some key components that are worth extracting and moving to benefit from these things, right? And this is the task for the future, to figure out which of these components will bring you value, which of them would be interesting to scale to give you some added value here. Not everything is interesting to scale, right? One PKI to rule them all, yes. And now we already have it when you deploy a Uyuni with MGR-ADM on Kubernetes. We're totally relying on Cert Manager to deploy the certificates. So this is something we already have. It's not a problem. We still have concerns on the certificates for the proxies yet. Because the proxy, when you have a proxy outside, the certificate is generated on the server side for now, and then this is for now we don't have a solution. It may be especially a problem because the proxy will surely not run on the same cluster than the server itself, right? Centralized logs? Obviously not. They're all in var log for now. So the thing is that as soon as we split one container, we can make one thing in a container. We can ensure that the logs are written in the proper Kubernetes way, so that they're in the std out or stdrs to have them and extract them. But we cannot have that for every log just now. It's a bit too much. But this is something that will come after we split. Automated deployments, yes, we have that. It was using MGR-ADM and a Helm chart. We have some sort of Helm chart, and we'll see later that we'll even push later, even furthermore on the Helm chart. So, are we there yet? So you probably guess that if we're here and talking about that, it's because we're not there yet, right? So it hasn't been only 5 minutes we're in the car, but a year or even a little more. But still, there's still some work. Before, let's look at the past. Look back at the past and where we're coming from on that front. That will help you understand the evolution of the thinking and what happens there. So first, the initial design. The initial design is that MGR-ADM drives it all. There was a spirit that you had one entry point that would deploy everything. Either you do it with the Podman subcommand or the Kubernetes subcommand, and boom. And it uses a Helm chart and deploys that Helm chart. That has drawbacks, bad drawbacks, because what happened is that we had to deploy that Helm chart at least 2 times during an installation of Uyuni. Once to get the container started, then you execute it. We had a kubectl exec to run the setup inside that big container that runs systemd as PID1. And once that is done, you redeploy to get rid of all the setup definitions that we had and have the final thing. yuck. Well, it's not. It's not exactly Kubernetes friendly, right? Other problem we have is that mgr-adm is creating a bunch of setup scripts that are bind mounted inside the container and then executed, and this is quite ugly, honestly. Bind mounts, whoa. So that required mgr. This one of the things that are requiring mgr-adm to run on the node. So that's bad. And that Helm chart had only two services, one for TCP ports and one for UDP port. It works. Why not? But it's not future-proof, right? We'll see that a little later. And mgr-adm, as I mentioned, has to run on the node first for the scripts, but also for when you're using a mirror for the packages, you had to have the mirror mirror being a path on the node, being host mounted. It's not exactly a good solution. The setup of port exposure is done using Nginx or a traffic, depending on what is your load balancer here and everything. Is defined in the configuration there. So that mean we had to deploy that traffic configuration on K3s node and get traffic to restart to expose all these service ports later. We'll see that it's not completely gone yet, but we're at least aware it's a bad thing. So then next step was why not writing an operator, right? An operator is a Go program that runs, basically it's a loop, an infinite loop, inside a container running in the cluster, and every time it detects a change, it applies it. And that loop has to be super fast, so you should not block. And if there's something that's not finished or not done, the loop, the next iteration, if you see, oh, this is not completely finished, it's in that state, I can do this now, let's do it, right? And in order for this to do that, to happen, I had to refactor a bunch of things in how we work, including in mgr-adm, and that also had Podman impact on Podman installations as well. So now the setup part is no longer done in the exec. It's a separate container that runs before everything. In Kubernetes case, it's running as a job. In Podman case, it's just a Podman run, and that's it. And we are not even bind mounting the script. It's just passed into the container definition. That's it. So this is pretty cool, but it required quite a substantial rework because the setup was relying on systemd to be running, which you cannot assume then. If you have the setup that runs as you have a setup script that runs, then you have to have no systemd then running, no systemd as PID1. So that required still quite some refactoring in the setup. And obviously, when you merge this thing and then you think everything is fine, you test it locally and then CI breaks. Oh, and you do it again. That's kind of dangerous thing still to change. So with that, we don't need to have any more redeployment. So it's only jobs that are running one after the other. For the setup, it's just one job, but for upgrade, we have like potentially 4 jobs if you have a Postgres database main version upgrade. So it's 4 different jobs that run one after the other. And the services have been split, so now we have 1 service per component. We even have one for the database, one for the report database, so that at one point we can have the service for the report database that could be exposed to the outside, but not the one for the internal database. So that as soon as we split one of these parts, we can route the service to the proper pod, and that's it, instead of having everything in one giant service. And to make sure that this would fit all in an operator, I had to merge all the install, upgrade, and migration functions code, which are somewhat similar, into a single function. It's not so easy to do. It has to be thought carefully, but it's done. It's doable. It's quite refactoring, but at least it's cleaner now. And yeah, what's remaining now to have MGR ADM running on that requires MGR ADM running on the node is only the Nginx or traffic configuration deployment on the node. That's the only thing that remains now. And so this happened in around September, October last year, this refactoring, and I wrote the operator in Go during Hack Week in November, if I recall correctly, the time frame for Hack Week. The first problem I had is that I had to define a Kubernetes API version, because in the Go operator, you're not passing the YAML file, you're defining the Go objects and set everything in Go objects and pass that. So when you add Go mod and add the Kubernetes API, you have to specify a version of the API. Why not? But that means it also adds a requirement on the Go version we use to build this, which can be a problem from time to time. And the main concern I have is that Kubernetes is going too fast for us. Kubernetes is releasing like one release every 4 months or something like that, right? And SUSE Manager is one every year, and we're supporting more than that. How can I get something like that? I mean, this is already a problem, just this version thing. So the operator experiment was interesting. I had something that was deploying the server, no problem, but I'm not sure it's the way to go. It adds too much complexity for us to maintain, because it's still quite a bit of code. It has big dependency on Kubernetes API, so probably not the ideal solution. And also another problem of the operator is that the operator needs to be given permissions. And the operator would have created secrets, config maps, pods, deployments, jobs. It's quite a bit of a permission set, right, for a single thing. And I'm not sure we would have managed to have the Kubernetes admins to say, hey, yeah, sure, you can run that thing on the cluster. So as I know there are mitigations. Some people are running the operator in a separate cluster, but still, yeah, it's not easy to convince admins for that. Well, I basically did that all. It went too fast. So technically, running a Uyuni Kubernetes works. All the features are technically available. The only one thing that is possibly a problem is proxy configuration generation, as mentioned about the certificate problem here. This is not solved, but the rest of it is working. Even PXE booting, right? That requires a UDP port exposed and so on. So that is working. Certificates are handled by whatever Kubernetes is providing. So cert manager, okay. I don't know if there's other TLS certificates generation tools, but that would, as long as it creates the certificates with the secret with the proper names, it's just okay. For now, we have cluster IP services, and this is a problem because in many cases people want to customize that and use load balancer services or node port or whatever. So this is something we need to change to have it more flexible, so that you can get that adapted to what you want. And this is also what imposes us to have Nginx or traffic to expose the port. So this is the problem. So as soon as we get a load balancer on top of that, we don't have that problem anymore. We're expecting a few things from the admin or well, at least the user. So volumes, obviously. But if you're using a storage class that's auto provisioning volumes, you don't need to bother the administrator. Just use that storage class. And the user needs to provide secrets also for the credentials, for things like that. So that's already there. So for now, yeah, MGR ADM is still running on the cluster node. Too bad. And now there's no more Helm chart. Well, the Helm chart is built, it's published, but it's not used anymore. So this is something to address. There's one thing also that's probably not pleasing. I don't know, you may tell me, is that the SSL redirection, we have a few big ingress rules for SSL redirections, because in the past it was, in the Podman case, it's even hardwired in Tomcat. So Tomcat, when it sees an HTTP request that's supposed to be HTTPS, sends a redirect to HTTPS. And in Kubernetes case, it's handled by an ingress. I've heard by someone that maybe they want to do also that differently. I don't know. I don't know if there are any other options for that. What are the limitations? So we still have one giant container. It's obviously not cloud friendly, right? We're on the process of splitting the database out, and it's a slow process because we don't have only that to do with many other things, right? And another thing is that we need to take care about our existing users, and Podman comes first. Whatever needs to be changed needs to be first Podman and then Kubernetes later. Which has some drawbacks, because we have a test suite that runs all the test suite that we run on the Podman deployment. We do the same on the K3S, but it gets less attention from everyone, and it's broken almost every time. There's still rough edges, as I mentioned, the proxy configuration things. So yeah, what can we do? So still some work to be done. And honestly, it's hard to get everyone in the team to pay attention to Kubernetes, even when developing features that could have some differentiation or so. I forgot to mention that why we started with Kubernetes in the beginning is that before in SUSE Manager 4.3 we started containerizing the proxy, and we did it for Podman first, and then we said, hey, let's go Kubernetes, and then we realized that our configuration is not exactly container friendly, Kubernetes friendly. We need to do that, to redo it again. And now I pushed hard to have both Kubernetes and Podman at the same time, so that we can anticipate Kubernetes-specific problems before it's too late. But still, it's hard to get everyone's attention on that. Going cloud-friendly is very hard because, as I mentioned, our code is 20 years old. So we don't change that in one night, even in a year, sadly. And in the team, we're like the code. We're legacy people. We come from the Linux world. Only a few of us have knowledge of Kubernetes, right? And that comes also to our challenges, because we need to get closer from the user's reality. For instance, I am CKA certified. Means, in theory, I know how to administer a cluster, right? But I never did it in real life. I never saw that happening at a customer, or how people are doing that, how even organizationally and in the different teams, how this is done. And that is big. That has a big impact on how we think about it all, because we only think about the theoretical aspect, not about the practical aspect. And this is a big challenge. And you can train whatever, get whatever training you want. Experience is something you still need at some point. And yep, not all the people in the team are Kubernetes aware or even Kubernetes friendly. Support is another problem. So suppose we have it all ready, right? Technically, everything is ready to go live. We have two support teams at SUSE. One team that is handling all Kubernetes-related problems, and one team that is handling all Linux and SUSE Manager related problems. If you have a customer running SUSE Manager on Kubernetes, and there's a bug, who's taking it, right? And that is a serious problem. So we need to have a way to identify and balance the bug one way or the other. And the scope of the support. You know, SUSE has K3s, RK2 distributions, right? But there are quite a few more in the wild. And on top of that, you can add storage, because there are different storage backends, network backends, and whatever. The support matrix is growing like crazy. And for now, we're just supporting SUSE Manager running on now two OSs. And that just blow up the whole thing. So the whole support thing is something that has to be defined, and we need to gather everyone around a table, say how we want this to be defined. I mentioned Kubernetes lifecycle is too fast. So this is also a problem. How do you want to handle that, the support with that? That can be tough. And time is also a big problem. I don't know about you, but I only have 24 hours a day. And we need to take care about our existing users. This is priority number one. And refactoring 20 years old code is hard. And adding Kubernetes on top of that, even more. So, and if you already also have legacy application that you're moving to Kubernetes, I suppose you're feeling the same pain that we have, right? So I mentioned the Helm chart, and let's talk about what I think would be ideal. And I'd like to go Helm chart only the Helm chart. The idea is I don't want to have to bother the cluster administrators, because it's an application. In theory, they should not have to provide anything. It would make people's life easier. Problem is that it requires heavy refactoring of the setup. That can happen over time. The setup needs data. They're used once. For instance, the administrator password. You have to define it in secret. But if you reapply the setup, maybe you want to have that, and the password has changed. Maybe you want that password to be changed again in the instance. Should it be only in the setup? So these are tiny things that could be interesting, that would be adding value and make it more cloud friendly. So it would be declarative. Probably cannot do it for everything, but it would be interesting to see what could be declarative and what could not. the Helm chart should need to be more advanced, and maybe we need even more than one Helm chart. I'm thinking about, for instance, about migration. When you migrate from 4.3 server that is RPM based to a container based server on Kubernetes, you probably want a Helm chart just for migration, and then you apply the other Helm chart to get it set up. That's probably an idea. Benefits, and this is the benefits of going Helm chart is obviously that everyone does Helm chart. It's something that everyone knows here in the Kubernetes world. So that's more aligned. And Helm charts, since it's using YAML, are less tied to the Kubernetes version you're targeting. As long as you're not using the latest fancy Kubernetes features, that should be okay, right? And MGR-ADM would not disappear, of course, but only for Podman, because there's no reason to use a tool to deploy a Kubernetes application in the end. Disadvantages is, well, since we get rid of the MGR-ADM fancy things and so on, it's not for Kubernetes newcomers, so you have to know what you're doing before. And that will introduce duplication between the Podman setup and the Kubernetes setup, because typically the setup scripts we have, or upgrade scripts or whatever that we generate in MGR-ADM, we'll have to copy them over in the Helm chart somehow. So it adds some duplication, but I had a look at Podman Kubeplay. I was saying, oh, why not? It was not ready 2 years ago when I first played with it. It seems there have been improvements, but it's not there yet. I mean, if I have a Helm chart that even is defining secrets, TLS secrets, for instance, in Kubernetes, you have 3 values inside the secrets. You have the CA search, you have CA key, you have the CA search, you have the certificate itself, and the key. And Podman secrets only have 1 value. So that means you would have 3 secrets. All tiny things like that. It means that on paper, yes, Podman Kubeplay can install a YAML thing, the Kubernetes YAMLs, but in fact, it's not usable for us yet, so we'll still have duplication. So this is the design, a design I'd like to start with, to go to. I add a big draft rubber stamp here because this is an idea I had after last time I managed to get some time to think about it. I didn't manage to implement it yet, right? So not there yet. So in theory, on paper, that should be okay, but I don't know all the fine details if that could work. The idea is that the server pod, server deployment would have an init container that would wait for the setup job to be finished. And if it's not finished, just stay here so we can articulate the different jobs and the pod with these init containers that wait. So I've seen that it seems to be a common practice in other parts of the Kubernetes world. So why not? In this diagram, everything that's red, a part of the draft rubber stamp, is things that would be provided by the user. So setup data, admin, the credentials for admin, or maybe even the other credentials, not only admin. SSL certificates, the PVs, either are automatically created or provided by the user. SSL certificates, they can be provided by cert manager, but as I mentioned, as long as it has the expected name, can be even manually created or anything else. One thing that I'm not totally sure about yet is the PostgreSQL database. Do we want to have that inside Kubernetes or outside, or managed by an operator. I know there are several operators there. I'm not totally sure, and this is something to be discussed, right? Okay, question over there. Maybe I just...
It's not really a question. It's more over my opinion about the Postgres SQL. I think it should be a choice for the one who's going to deploy the environment. If you want it in your Kubernetes environment with a persistent storage and all that kind of environment on it, it will be your choice. Or just a separate server on bare metal or whatever, in a virtual machine with its own storage. I think, yeah, it should be a choice.
Okay.
Because not everyone wants to run a database on Kubernetes.
Yeah, and that's something I feel like as well. It's something that we cannot impose. Running PostgreSQL database on Kubernetes doesn't always make sense, in fact.
Yeah, since I know I used Spacewalk quite a long, it's database heavy.
Yeah.
So if you're, for example, on AKS or on EKS, it will cost a lot of money for you.
Okay. And the other thing is here, in the example, I added MetalLB as load balancer here. I know there are other load balancers. Some are even not open source or paying or whatever. So probably whatever load balancer you're using could be interesting. Maybe even NodePort could be usable. I have no clue how that would work with UDP, and maybe you have your own redirection or IP tables or what on top of that to point to the proper ports. But yeah, NodePort. I have the feeling that it might be more complicated, right? So this is about the idea. And the fine word is that we need you. We need your help because, like I said, we're a bunch of legacy people. And any help, any feedback is much appreciated. And we can't talk about that here. If you have questions, feel free to grab a microphone here or even come down later at the demo kiosk for Multi-Linux Manager. We can have a chat about that. Happy to have that. And even if you want to have a proof concept, I'd like to have a proof of concept SUSE Manager running on Kubernetes with a few selected customers with limited set of features needed for basically, because obviously running the full thing at first thing would be too much complex. But if we can have proof of concept, that could be interesting to get learning experience on if we're doing right, if that would fit at least these customers' use case, and if it fits one or two users' customers, maybe it will fit way more. So, any question?
So as someone from the Kubernetes world who's not a Tomcat dev, how can we help?
It's not all. Everything is not all on Tomcat. Basically, all the Helm chart and to help on the setup and everything is much appreciated. Typically, all these networks aspects, I have some ideas, some clues about it, but I'm not super familiar with that. I have some knowledge of the Kubernetes ecosystem, but I'm a newcomer. Come on. So even talking and knowing how you guys are doing Kubernetes applications in your enterprise, in your company, that already is a big plus. Just getting feedback.
Yeah, so talking from the edge side, I think the one thing we need to figure out is what are the actual use cases? Where are people using SUSE Manager together with Rancher mainly? And that will then determine a bit like, is it really important to focus on splitting stuff more up and so on. Giving an example, we see people asking, okay, can we use Salt to do some pre-configuration before the cluster comes up? Because there's stuff that you cannot easily do with Rancher or Elemental, but Salt can easily do, like deploy an SSH certificate. It's just easy. And in that case, it's more like, can I maybe have a fleet GitOps automation that goes into both SUSE Manager and the Rancher side? Whether the SUSE Manager is running as a VM or Kubernetes based is not really the main problem here, but of course it would be nicer to have the Helm chart. But that would, for example, determine, do we even need like a UI for SUSE Manager, or would it be running headless as just an API server? And then, the Salt, one of the problems that aren't fully resolved is where, at the moment, there are the Salt states that are installed, but it's very hard to, inject your own stuff because you don't have root access on the file system anymore. And I'd see that more like, okay, can we put that into Git, for example, like basically have, because then SUSE Manager would be much less stateful. Yeah, we would just say, okay, and that's what everyone else is doing. Like Rancher, you bring it up and then you just say, okay, this is where your Git, your fleet repo is, and you don't have to have that on disk somewhere or have PVs for it.
And maybe I can give you also a small interesting fact. It took us several weeks, if not months, to figure out the list of volumes we wanted to have. Because it's so huge, that thing is, we're so used to have everything in one server that when you extract the thing and then we need this and this and this folder. So obviously there were a few well-known folders, but we discovered some more. And just figuring out what is useful and what is not. I think what would be cool is to gain some scalability on some parts. I mentioned that, maybe, I can't remember if I said that here or earlier to someone else, maybe both. One of the things that is heavily used by on SUSE Manager is the download endpoint. The download endpoint is used by every system that pulls packages, right? And this thing is one endpoint on one Apache server that is rerouting to a Tomcat now. Why wouldn't be extracting this one thing and make it scalable? It's stateless in the end. Well, almost stateless because you need the RPMs themselves, and this would be bringing value, right? But I don't think we can extract anything, or we need to think carefully what would bring value in extracting and making it more container friendly.
Yeah, that's one of the things. You said it doesn't help with scalability, but to some extent, just the automation helps, because I can much more easily set up multiple SUSE Manager servers that are very close, and then either use the hub or do some sharding, because it's not as complicated as setting up every Snowflake SUSE Manager server anymore. So that's a good thing, even if it doesn't scale just on Salt or just on the file system or just on the Apache side. And then, of course, you don't have the shared. In theory, you could even have then a shared database with different namespaces. But anyway, so it's already improving things. And we have a few of those projects where we are looking at hundreds of thousands of nodes to manage, where we would have to do something like that anyway.
We have to stop the discussion now. I think we're 4 minutes over time. Thank you all for the discussion and your attention. And we can continue the discussion outside of the room so that we can leave it for the next speaker.